Artificial intelligence is a vast field, but when it comes to machine learning, two major approaches stand out: generative AI and discriminative AI. Understanding the difference between these two is crucial for anyone interested in how machines learn and make decisions. In this video, we'll break down what each type means, how they work, and where you might encounter them in real-world applications. Let's start by setting the stage with a quick overview of what generative and discriminative models are, and why this distinction matters in the world of AI. Generative AI refers to models that can generate new data instances similar to the data they were trained on. These models learn the underlying patterns and structures of the data, allowing them to create entirely new content. For example, generative AI can produce realistic images, write coherent text, or even compose music. The key idea is that generative models try to model how the data is distributed, capturing the joint probability of inputs and outputs. This ability to create and imagine makes generative AI a powerful tool in creative and scientific fields. Discriminative AI, on the other hand, focuses on distinguishing between different kinds of data. These models learn to classify or predict labels by modeling the boundary between categories. Rather than generating new data, discriminative models excel at telling the difference between, say, a cat and a dog in an image. They estimate the probability of a label given the input, making them highly effective for tasks like spam detection, image recognition, and speech classification. Discriminative AI is all about making accurate decisions based on existing data. Generative models work by learning the joint probability distribution of the input data and their labels. This means they try to understand how data points and their categories relate to each other. By doing so, they can generate new examples that fit within the learned patterns. For instance, a generative model trained on handwritten digits can create new, realistic-looking digits that were never part of the original dataset. This process involves complex mathematical modeling, but the result is a system capable of creativity and synthesis. Discriminative models take a different approach. Instead of modeling how data is generated, they focus on the boundaries that separate different classes. These models learn the conditional probability of a label given an input. For example, given an image, a discriminative model predicts whether it's a cat or a dog. The emphasis is on making precise distinctions, which makes discriminative models highly effective for classification and prediction tasks. Their strength lies in their accuracy and efficiency when it comes to sorting and labeling data. Generative AI has made headlines with impressive applications. Think of AI systems that can write stories, generate artwork, or even create deepfake videos. Tools like GPT for text generation and DALL-E for image creation are prime examples. These models don't just mimic, they invent, producing content that's often indistinguishable from what a human might create. The creative potential of generative AI is vast, opening up new possibilities in entertainment, design, and beyond. Discriminative AI powers many of the tools we use every day. From email spam filters to facial recognition systems, these models are behind the scenes, making quick and accurate decisions. For instance, when your phone unlocks using your face, a discriminative model is at work. Similarly, when you search for images of dogs online, discriminative AI helps sort and classify the results. Their reliability and speed make them essential in countless applications. Their core generative and discriminative models serve different purposes. Generative models aim to understand and recreate the data, while discriminative models focus on distinguishing between categories. This fundamental difference shapes how each type is used and what problems they're best suited to solve. Understanding these distinctions helps in choosing the right approach for a given AI task, whether it's creating new content or making accurate prediction. Generative models are built on the idea of modeling the joint probability distribution. Know it as P, X, Y. Where is the input and Y is the label? Discriminative models, in contrast, model the conditional probability P, Y, X. This mathematical distinction is more than just notation. It reflects a fundamental difference in how these models learn from data. Generative models try to capture the full picture, while discriminative models zero in on the decision boundary. Some of the most well-known generative algorithms include naive Bayes, hidden Markov models, and generative adversarial networks, or GANs. Each of these has unique strengths and applications. For example, GANs are famous for generating realistic images, while hidden Markov models are used in speech and language processing. These algorithms showcase the versatility and creative power of generative AI in action. Discriminative algorithms include logistic regression, support vector machines, and most neural networks used for classification. These models are designed to draw sharp boundaries between classes, making them ideal for tasks like image recognition and spam filtering. Their focus on accuracy and efficiency has made them the backbone of many practical AI systems in use today. Generative models often require more data and computational resources because they need to learn the full distribution of the data. Discriminative models, by focusing only on the boundaries, can sometimes achieve high accuracy with less data. This difference in data requirements can influence which model is chosen for a particular problem, especially when resources are limited. Interpretability is another area where generative and discriminative models differ. Generative models, by modeling the data distribution, can sometimes provide deeper insights into the data itself. Discriminative models, while often more straightforward in their predictions, may not offer as much understanding of the underlying data structure. This trade-off is important when transparency and explainability are priorities. Generative AI shines in creative tasks. It's used to generate realistic images, write stories, compose music, and even design new products. In scientific research, generative models help simulate complex systems or generate synthetic data for experiments. Their ability to imagine and create makes them invaluable in fields where innovation is key. Discriminative AI is the workhorse behind many practical applications. It's used in medical diagnosis, fraud detection, and quality control in manufacturing. Whenever there's a need to classify, sort, or predict based on existing data, discriminative models are often the go-to choice. Their reliability and speed make them essential in high-stakes environments. Generative AI's main strength lies in its creativity. It can produce new data, fill in missing information, and simulate scenarios that haven't been seen before. This makes it especially useful in fields like design, entertainment, and research, where the ability to generate new ideas is highly valued. Discriminative AI excels at making accurate and efficient decisions. Its focus on classification and prediction means it can quickly and reliably sort data, making it ideal for real-time applications. Whether it's detecting spam or diagnosing diseases, discriminative models are trusted for their precision. Despite its strengths, generative AI can be resource-intensive and sometimes less accurate in classification tasks. Training these models often requires large datasets and significant computational power. Additionally, because they try to model the entire data distribution, they may not always be the best choice for tasks that require quick, precise decisions. Discriminative AI, while highly effective for classification, doesn't offer the same creative capabilities as generative models. It can't generate new data or simulate scenarios outside of its training set. This limits its use in creative or exploratory tasks, where the ability to imagine new possibilities is important. Great example of generative AI in action is text generation. Models like GPT can write essays, poems, or even code by learning from vast amounts of text data. They don't just copy, they create, producing original content that can be tailored to specific styles or topics. This capability is transforming industries from publishing to customer service. Discriminative AI is behind the image classification systems used in everything from social media to medical imaging. These models can quickly and accurately identify objects, people, or even diseases in images. Their ability to process large volumes of data with high accuracy makes them invaluable in many fields. Artists and designers are increasingly turning to generative AI to create new forms of art. These models can generate paintings, music, and even sculptures, often blending styles in ways that humans might not imagine. The collaboration between human creativity and AI's generative power is opening up exciting new frontiers in the arts. In healthcare, discriminative AI models are used to diagnose diseases, predict patient outcomes, and assist in treatment planning. Their ability to analyze complex medical data and make accurate predictions is helping doctors provide better care and improve patient outcomes. Generative models are also used to create synthetic data for training other AI systems. This process, known as data augmentation, helps improve the performance of discriminative models by providing more diverse training examples. It's a powerful way to overcome data limitations and enhance machine learning. Security systems often rely on discriminative AI to detect threats, identify intruders, or flag suspicious activity. These models are trained to recognize patterns associated with security risks, making them a critical component in modern safety infrastructure. In scientific research, generative AI is used to simulate complex systems, predict molecular structures, and even design new drugs. By generating realistic data and scenarios, these models help scientists explore possibilities that would be difficult or impossible to test in the real world. Financial institutions use discriminative AI to detect fraud, assess credit risk, and automate trading. These models analyze vast amounts of financial data to make split-second decisions, helping protect assets and ensure smooth operations in the fast-paced world of finance. Game developers use generative AI to create new levels, characters, and storylines. These models can generate content on the fly, making games more dynamic and engaging. The ability to create endless variations keeps players entertained and coming back for more. Marketers use discriminative AI to segment audiences, personalize recommendations, and optimize campaigns. By accurately predicting customer preferences, these models help businesses deliver targeted messages and improve engagement. Generative AI models are making strides in language translation by generating natural-sounding translations that capture the nuances of different languages. These systems don't just translate word for word, they generate contextually appropriate sentences, making communication across languages smoother and more effective. Customer support systems use discriminative AI to classify and route inquiries, ensuring that customers get the help they need quickly. These models can understand the intent behind messages and direct them to the appropriate resources, improving efficiency and satisfaction. In robotics, generative AI is used to simulate environments and train robots to handle new situations. By generating diverse scenarios, these models help robots learn to adapt and respond to unexpected challenges, making them more versatile and capable. Transportation systems use discriminative AI to recognize traffic signs, detect obstacles, and assist with autonomous driving. These models process sensor data in real time, helping vehicles navigate safely and efficiently through complex environments. Educational platforms are leveraging generative AI to create personalized learning materials, quizzes, and even interactive simulations. By generating content tailored to individual students, these systems help make learning more engaging and effective. E-commerce platforms use discriminative AI to recommend products, detect fraudulent transactions, and personalize shopping experiences. By analyzing customer behavior, these models help businesses boost sales and improve customer satisfaction. Musicians and composers are exploring generative AI to create new melodies, harmonies, and even entire songs. These models can blend genres, experiment with styles, and inspire artists to push the boundaries of what's possible in music. Social media platforms rely on discriminative AI to filter content, detect inappropriate posts, and recommend relevant feeds. These models help keep online communities safe and engaging by making real-time decisions about what users see. Fashion designers are using generative AI to create new clothing designs, predict trends, and even generate virtual models. By analyzing patterns and styles, these models help designers innovate and stay ahead in a fast-moving industry. Manufacturing industries use discriminative AI to inspect products, detect defects, and ensure quality standards are met. These models analyze images and sensor data to catch issues early, reducing waste and improving efficiency. Pharmaceutical companies are leveraging generative AI to design new molecules and predict how they might interact with biological systems. This accelerates the drug discovery process, potentially leading to faster development of life-saving treatments. Law enforcement agencies use discriminative AI to analyze surveillance footage, identify suspects, and predict crime hotspots. These models help improve public safety by providing actionable insights from vast amounts of data. Virtual reality experiences are becoming more immersive thanks to generative AI, which can create realistic environments, characters, and scenarios on demand. This technology is transforming gaming, training, and even therapy by making virtual worlds more dynamic and engaging. Voice assistants like Siri and Alexa use discriminative AI to understand and respond to spoken commands. These models classify user intent and trigger the appropriate actions, making everyday tasks easier and more convenient. In deciding between generative and discriminative AI, it's important to consider the specific needs of your project. If you need to create new data or simulate scenarios, generative models are the way to go. For tasks that require accurate classification or prediction, discriminative models are usually the better choice. Understanding the strengths and limitations of each helps ensure the success of your AI initiatives. Summary: generative and discriminative AI represent two powerful but distinct approaches to machine learning. Each has its own strengths, weaknesses, and ideal use cases. As AI technology continues to evolve, we can expect even more innovative applications that blend the best of both worlds. Staying informed about these developments will help you make the most of what AI has to offer, whether you're a developer, researcher, or simply an enthusiast.